Bismillah Rahman Rahim. Assalamu alaikum, my dear students. Today we're going to start to learn about the energy content of fuel. For this, you need to open your textbook page number 193. That is your chapter number 15. So let's dive into topic. What is about this? Welcome, Amro. Thank you very much, my dear. One of the main factor to think about choosing a fuel is its energy content. It's very easy to understand when you're going to choose something for your eating purpose, or you're going to choose some food or any drink. You will see that this drink that is cool, it's tasty, yummy, or you can say that sweet, whatever you wanna find in the drink. In the same way, if you're going to take a tea, you will choose that it should be hot and the amount of sugar or whatever the content in it. Do you like these things? In the same way, when you're going to choose any fuel, you will see that the amount of energy in it, how much energy is present in your fuel. So that is the most important thing for you to compare this across different fuels. We should look at energy released per gram of fuel burnt. Please everyone understand and underline this statement. What is meaning? Fuel should be took at the energy release per gram of fuel burn. What it means? When you're going to burn 1 gram of fuel, how much energy it released? It's very easy. The amount of energy that it's going to release, but before you know that the amount of fuel, you will take 1 gram of fuel, then you start to burn it, and after that burning, you will going to find out or calculate the amount of energy released. It is little bit interesting for you to know that how we going to manage, find, or you can say that calculate the amount of energy that is released. For example, when you're going to burn a piece of paper or a piece of wood, how can you calculate the amount of energy is released from there? For this, there are few instruments that we will discuss inshallah today's topic. But before to go there, let's see this. To get this information by experiment, you need to carry out a fair test. For this all, you need to perform a practical, a test, but that should be fair. There will be no fake readings. The only variable that should change each time we collect data is the type of fuel. Every time what we change, we're just going to change the fuel. Maybe sometimes you choose kerosene oil, sometimes benzene, sometimes you use petrol, sometimes you use diesel. So these are the types of fuel, coal, gas. So these all are the fuels, types of fuels that you change. But the data after that collected, there will be not a same result. There will be some differences. So let's see how this happened. To make the investigation valid, we want the energy released as the fuel burn to heat up the water. At that point, what you do and how you calculate what the energy released when you're going to burn something. For example, as I show you here, like this, you put something in it, okay, and you let it to burn. When that start to burn, you put a beaker here on it, and in this beaker what you done, I just give you an example here. You put a thermometer. So this you fill with water. After burning of fuel, maybe you took 1 liter of fuel, okay? And when you start to burn this, when this all fuel is burned, you will see the temperature of the water, how much rised in the temperature of the water from the reading by the thermometer that you dipped in that water. I just gave you this simple example to you, but actually we are going to perform another practical. So let's see. Fuel burn to heat up the water. See the investigation 15.2 below. That will be there. Therefore, we use a copper beaker, what we name it as calorimeter. So before to go there, I'm going to share a screen with you from where you should know about the calorimeter. What is a calorimeter? Just a minute. Yeah, now it's just going to uploading. Yeah, one is here. Majid is now joining us. Okay, this the now everyone can see the diagram of calorimeter. Now I just make it little bit slide share, so it will be more easy to understand about that. So here, now that is the thermometer that you dipped in the water. Okay, it's the stirrer. You use it to just move the water. Here, this is the reaction mixture, and that is your styrofoam cups. So actually, what this meter going to do, whatever the energy, whatever the heat you give to that instrument, it will not let a very little heat out from that meter, because that is covered with styrofoam and also covered with lid. It will going to let all heat just to use to increase the temperature of the water, and then you can get accurate and correct value and valid result from the thermometer. Till here, my dear students, if you have any question, please raise your hand, otherwise type no. Yes, Ahmad Musab.
Sir, we will put the burn, when we burn nothing, we'll put it in the styrofoam cup.
Yes, we will put this calorimeter on that fuel. Okay, yes, Hussein.
Yes, teacher. Teacher, what is the stirrer? The
Stirrer?
yes.
Stirrer
Yes.
is, it's just we use to shake the mixture, okay? Understand? Okay.
Okay, yes.
Okay, and one no is enough for me, please. No need to send more no's here. Okay, now you know about the calorimeter. Why is the beaker made of copper? That is your assignment, this one. Second question, why do you think that the copper beaker is called as calorimeter? So these two questions that are your assignments. You will tell me in the chat or even on WhatsApp. Okay, my dear? Question number 1, that is your assignment. Why is beaker made of copper? And second, why do you think that the copper beaker is called as calorimeter? Now, you will also need to weigh how much fuel is used in each test. As we know that we every time going to measure first per gram of fuel, because if you're not going to measure the amount of fuel, your result will change it every time. Why? Because sometimes you burn more fuel and it will make your water more hot as compared to the small or little amount of the fuel. After that, okay, thank you very much. That's great. Inshallah, we will discuss after that. Someone just send me the answer in the chat. Okay. Then you can work out how much energy in joules is transferred to the water using this equation. So that is very important equation. Please everyone concentrate and focus on it. Energy. Energy, the unit you measured in joules. Okay, that is represented by J. Mass of water, that is in grams. Number 2, that is equal to specific heat capacity of water. That is already given. Okay, you no need to find out this. You just need to know the mass of water in grams and rise in temperature. From where you can find the rising temperature? From the thermometer. From the thermometer. That is in centigrade. So to convert this energy into the amount of energy per gram, we use energy per gram, energy released in joule divided by mass of fuel. Simple equation, and that gives you the amount of energy as per gram. Till here, if you have any question, please raise your hand, otherwise type no. Hurry up. Yes, my dear.
Mr. In specific heat capacity of water,
Yeah.
he took all.
Yes, they already given you for all materials what is their specific heat capacity, that is already given in the data. You no need to find. You just need to know about the mass of the water and rising temperature. Okay.
Okay.
Thank you very much. Now, yes, Ahmed Musab.
Mister, what is the capacity of the water?
A specific heat capacity.
What is capacity?
Yeah, for example, it's just, you can say, ability. Okay, it's very easy to understand. I will give you the answer of that question. Listen me carefully. Now, to tell you at what temperature water start to boil. Everybody knows that at 100 degrees Celsius, when the temperature of water reached at 100, it start to boil. So in the same way, every material has their own heat capacity. After that, they can't absorb more heat in them. When the temperature will be 100, how much you're going to increase the temperature? No change in temperature. Okay, because the maximum capacity of water to absorb heat, that is 100 degree Celsius. Now, hope you understand. Thank you very much. Now, let's see the example that will help you to understand the equation. Okay, so please, everyone, I'm going to read the statement. Now, the statement is mentioned here. You have 2 grams of fuel. The amount of fuel is 2 grams. Raise the temperature 100 grams of water. The amount of water or the grams, that is 100 by 25 degrees Celsius. If you use grams of fuel, okay, that raise the temperature of 100 grams of water to 25 degrees Celsius. How many energy does the fuel gives out per gram? Now you're going to find out in per gram what the energy is. So here they mentioned that the specific heat capacity of water, that is 4.2 joules per gram per centigrade. This means that it takes 4.2 joules. Now you put all the data in the equation like this. Mass of water, that is 100. Okay. Second thing, specific heat capacity, that one, 4.2. Now the third thing, rise in temperature, that is 25. Now you put it here. Now multiply all of them, you get the energy in joules. Now what do you find? Water by 1 second. Just me to raise this 1 minute. Now here, of energy to rise the temperature of 1 gram of water by 1 centigrade. So that gives you, that is equal to amount of energy per gram, 1050 divided by 0.2 grams. So when you divide it, this, it gives you 52.5 kilojoule per gram. So that is your per gram energy that you get from this fuel when your fuel is 0.2 grams. Till here, if you have any question, please raise your hand. Otherwise, type no. Hurry up. Thank you. Well done. Excellent, my dear. Okay. Now here, thank you very much. Thanks, my dear. Now, after that, here we almost have the last part of today's lesson. That is about what? So let's see about this. Now comparing fuel. When you're going to compare one fuel to another, what's happening? You can compare the heat content of different alcohols using the apparatus opposite. This apparatus you can use and you can find out which fuel or which alcohols gives you more heat and less heat. How? It's very easy to see that. Let's to perform here each step. Now, design a fair test. You will put the alcohol in this split lamp, that is a block, wooden block that you use to just give heat near to the beaker. Fill this beaker with water and you use this beaker of copper. Okay, my dear, or you can say that as calorimeter, and put a thermometer in this water. Now, what you need to do, just start the burning of this burner. Remember to weigh your sprit burner and its fuel before and after heating the water. When you're going to start this experiment, first you need to weigh this burner. Why? Because you should know the amount of fuel that you added in it. After and before burning, you should wait again. For example, before, the weight of the burner is 10 grams. After burning 5 minutes, you again weigh that burner, that will be 5 grams. Now, minus 5 gives you 5. So the change in weight, that is equal to 5, which means you just burn the amount of fuel during this experiment, only 5 grams of fuel. When you will see that your 5 grams of fuel, how much that raise in temperature of water with the help of this thermometer. Okay, work out the energy content of each alcohol in joules per gram. Can you see any pattern in your data? Look at the formula of each alcohol. So you know that if anything like OH group, when you're going to attach this one, that gives you alcohol. There you're going to change the number of carbon and hydrogen, that gives you different types of alcohols. Use secondary data if necessary. What are the main source of error in your investigation? You should also find the answer of this question. And the last part and the last assignment for you, how could you improve the reliability of your data? Whatever the result you get, how should be more reliable? So my dear, that is all about today. Till here, if you have any question, please raise your hand, otherwise type no. Well done. Okay, that's great.